Hi, welcome to some examples, part 1 of questions involving our resolving forces skills. Right, so we have Amelia here who's hanging from this point. So we assume equilibrium. That means that the forces vertically are equal and the forces horizontally are equal. So there's no resultant force here at all. So what we would look at doing is let's resolve horizontally. Now if you look here, this force T2, this angle is obviously 30 and its component therefore is T2 cos 30. We're moving through the angle of 30, so it's cosine. Here this is 20, so this component is T1 cos 20. So we know that T1 cos 30 equals, T1 cos 20 equals T2 cos 30. So we have one equation involving T1 and T2. If I now resolve vertically, forces vertically are equal. Downwards, so resolving vertically, downwards we have Amelia of 50 times acceleration due to gravity. And upwards we have the component of T2 in this direction. This one was cos 30, so this one must be T2 sine 30, and similarly our other component T1 acting up is T1 sine 20. So if you look here, I have another equation in just T1 and T2. Now however you want to solve those, up to you. You might want to write this one in terms of T1 and then substitute into here and rearrange and get T2. I'm not going to do that for you. T1 equals 555 newtons is what you should get, and T2 equals 602 newtons. So please work through it yourself to make sure that you agree with those answers. So next example, looking at Cedric pulling this box. Okay, let's look at some keywords. Rough. Okay, this surface is rough, so there's a frictional force. Now it moves with steady speed. That means some of all the forces are zero. Okay, its speed is not accelerating, it's not decelerating, so its forces in any given direction equate to zero. So let's resolve horizontally, and we have the component here of Cedric's forces pulling with. We're moving through the angle, so that's x cos 20, and that equates to the force in this direction here, which is 10. So obviously we can easily rearrange that. Oh, okay, it's a funny looking x, and get x is equal to, let me just check am I working, 10.64 newtons. Similarly, we can resolve vertically. We know this force acting down of 10g is equal to the reaction force, so that's 10g is equal to the reaction force R plus, and this lots of people forget, this also has a component vertically. Horizontally its component was x cos 20, vertically its component would be x sine 20. Now we've found x, yippee! So we can easily just find r from that equation, and we know that r is equal to 94.46 newtons. Now it's also asked us to find the coefficient of friction, mu. Now because it's moving at steady speed, we know friction has reached a maximum, so we can write that friction is equal to mu multiplied by r, the normal reaction. We know the frictional force is 10, we don't know mu, we know that the reaction force we've just found is 94.46 newtons, so from this we can get that mu is equal to 0.46 1, 1. There you go, it's the first part of applying resolving forces to problems. Thank you for listening.